My name is BreonaSmith, and my research was done on the exploratory analysis of spatial temporal crime data in Washington, D.C. Here's my agenda, and these are the agenda points I will hit as we move through the slides. For my geographical problem, these are the goals that I wanted to achieve. I wanted to examine the socioeconomic determinants of crime, analyze trends and patterns of crime data, and identify how to use the space and time dimensions of crime data to identify clusters of low and high incidence. I used DC crime data over a 3-year period from 2018 to 2020. The attribute data includes offense type, police shift, ward, census tract, and was provided by the Metropolitan Police Department. Also, I used American Community Survey data provided by the Census Bureau. This demographic data included median income, population, education attainment, below poverty, and race of Black, white, and Hispanic. This was my process from start to end, my methods. First, I wanted to answer the question of what month crime was likely to happen and what season crime was likely to happen. So I added month and season to the attribute table, and then I created a line bar and heat chart to visually show that trend of change within that 3-year period, 2018 to 2020. Also, I created a space-time cube, and that cube was then used to create an emergent hotspot analysis. Next, for the ACS data, I summarized the crime data incidents within each census tract. Then I enriched that data with demographic data and ran my regression analysis. The first analysis I did was the Pearson Correlation analysis. This analysis allowed me to see to measure the strength of each variable between each other. So measure the relationship between each variable. As you can see, as it gets closer to positive to 1, it's a positive relationship. As 0 shows that there is no relationship, and -1 shows that there is a negative relationship. So as you can see, median income and crime count has a -0.1 coefficient, showing that there's a negative relationship between the two variables. It shows that one variable is decreasing and one is increasing. Crime count and below poverty rate has a coefficient of 0.2 and shows that there is a positive relationship between the two variables. However, that relationship is weak based on a 0.2 coefficient. Next, I used creating the space-time cube and emergent hotspot analysis. And the space-time cube allowed me to take the crime incident points and put them into bands. So my distance interval was 30 meters. This was the space dimension for the distance, and I had a time interval of 1 month. So any point that fell within 30 meters and 1 month would be in the same band, and so on. This created the space-time cube. And from the space-time cube, I was able to do the emergent hotspot analysis, which allowed me to predict high and low clusters of crime incidents within the DC area. Next was the exploratory regression analysis. This analysis allowed me to look at all possible combinations of variables that would explain my dependent variable. My dependent variable was crime count, and the explanatory variables used were median income, population, education attainment, below poverty, and race of Black, white, and Hispanic. For my results, the first results is a calendar heat chart. As the shades of blue get darker, the crime incidents have a higher value, and the lighter shades of blue show that there is a lower value of crime incidents. So from 10 a.m. to 10 p.m., you can see that there is an increase of crime within the city of DC. And from 12 o'clock to 9 a.m., there was actually a decrease in crime. This 12 a.m. to 9 a.m. window actually correlates to when most citizens are sleeping within the city of DC. And the 10 a.m. to 10 p.m. window shows that correlates to when most people are out and about in the city. The same trend can be seen in 2019. It shows that 10 a.m. to 10 p.m. has a numerous number of dark shade blocks, showing that there is an increase of crime between those times. And as I said before, the 0 to 9 a.m. window shows that there is less crime between that time window. 2020 also shows that pattern. It shows that most crime is done between 10 a.m. and 10 p.m. This time actually corresponds to the day and evening shift of the police department. Also, I wanted to dive deeper into a specific offense. So I added homicide to the calendar heat chart. It shows that homicide was only done at midnight, and it was done increasing it was likely to increase on the weekend where there was darker shades of blue. Also for robbery, it shows that robbery was likely to be done between 6 p.m. and 6 a.m. And it was likely to be done on a weekend. This shows that most people are in the house, and robbery is a force of taking. When you are forced to take people. When you are forced to take people things, so most people are in the house at that time. So robbery is correlated to when most people are in their homes, and is less likely to be happen in the daytime. The other results, this is a line chart. It shows what month crime is likely to happen. And this shows that July, August, and September, the summer months, are likely to have more crime. However, for 2020, it shows that more crime was likely to happen in the wintertime. And as the year progressed, crime was increasing. And this corresponded to the COVID restrictions. Some bans were lifted during the late summer and fall time. So I believe that increase can be correlated to COVID restrictions, the lifting COVID restrictions. These maps show violent crime and a property crime, and it correlates it to the median income within the area of Washington, D.C. So for homicide, a violent crime, it shows that most crimes are done within the Southeast area, and this correlates to a lower median income. The burglary in the northwest corner of DC correlates to a higher median income. These are the emergent hotspot output maps. For 2018 in the northwest corner of DC, this is where most tourism is done and where all the monuments and the White House is located. The dark red shows that there is an intensifying hotspot, meaning that these bins are statistically significant 90% of the time, and the high count increase over all time intervals. The darker blue shows that there is a persistent hotspot, showing that they are 90% statistically significant 90% of the time. However, they increase or decrease. And as we move to 2019, that same area has intensifying hotspots. As you can see, some of these turn into persistent hotspots, meaning that they were statistically significant 90% of the time, and they increase and decrease. And on the outer skirts, it shows a sporadic hotspot, meaning they're off again, on again hotspots. And as you can see, some of the cold spots turned into intensifying cold spots, meaning that they're statistically significant 90% of the time, and they increasingly cold over that 90%, over every time interval. For 2020, you can see that same area, more bends turned into persistent hotspots, meaning that they were statistically significant 90% of the time. However, they increased or decreased. And on the outer skirts of that big group of bends, you can see the oscillating hotspots. This shows that for the last time interval, that the hotspot was hot, but prior to that time interval, those time intervals were cold. For my exploratory regression analysis, as you can see the red box, this analysis helped me to put combinations of the variables that I chose together to see if they would explain the dependent variable, which was crime count. Population shows that, the first one under the red box, population shows that it had an adjusted R-squared of 0.20. This is a very low adjusted R-squared. Also for the AIC, which tells me the quality, how good my population data matches the model, it's lower than the other one. So for this summary, this was the best model. However, as I ran through all summaries, no passing model was chosen based on the criteria that I chose for this tool in ARC. And all adjusted R-squares for each summary were below 0.21. You can also see the SA. The SA is 0. It shows that the data is randomly dispersed. And the JB test of 0 shows that the data had a normal distribution. As you can see also, the BIF, it measures whether two variables have the same effect. So as you see down here, the VIF is high. It shows that one of these variables has the same effect as the other. So in order to get a better model, you would take one of the variables out that has the same effect as the other to try to see if you can get a passing model. For my conclusion, I identified that crime was likely to happen in the summer season based on the 2018-2019 period. However, crime decreased in the summer season in 2020. I highlighted there were significantly high clusters of crime all 3 years in DC Northwest quadrant, determining where resources should likely be allocated. Also, I estimated that all explanatory variables chosen had less than 20% effect on the dependent variable when ran using regression analysis.